Hi everybody, today's lesson will be about simplifying radicals. So a radical is a square root. That's the kind that we know. There are other types of roots out there, but this lesson will be focusing on a square root. And our goal is to simplify radicals exactly. And that means there will be no decimals. So in order to simplify a radical, it's important to break up the number underneath the radical into its factors. So I know that 32 is 2 times 16, and 16 is 4 times 4, and each of these 4 times 4s are 2 times 2, and I like to bring down that original 2 so I don't forget about it. So when we talk about a square root, it means that we're looking for 2 of a kind. So you could write a little 2 there before you write the root, but in practice we don't. So I'm looking for 2 of a kind. So I have 2 2's right here and 2 2's right here with 1 left over. So for every group of 2, I get to bring out one of them out front of the radical. So in this case I have 2 2's out front because I had 2 groups. And then under my radical, I had this 2 right here that was left over. So that has to stay underneath the radical. But make sure that you're doing all the math. So we want to do 2 times 2, which is 4 root 2. So when I look at part B, it's important to recognize that there is a 2 in front right now. And we don't want to forget about that through the course of the problem. So again, I'm taking 125 and I'm going to break it up. And you can use your calculator and think about this or however you want, but 125 is 5 times 25, and then I know that 25 is 5 times 5, and I like all my factors to be on the same level. So I can say, okay, I have a group of 2 with a 5 left over, so any group gets to go out in front of the radical. So I can bring the 5 out front, one group, so 1 5, but I also have a 2 there. And then underneath the radical, I had this extra 5 left over. So I do have to multiply here. I do have to do 5 times 2, which is 10 root 5. So if you have anything in front, you're going to multiply with any additional numbers that end up out front. But just make sure you don't forget about it. So that's how you simplify a radical. There are 2 properties of radicals that we're going to use for simplifying the next few problems. First is the product property, which says if you take the square root of a times b, you can separate those to 2 different radicals and multiply together. The same is you can go both directions. So if you're multiplying 2 radicals, you can combine them and multiply them underneath one radical. And the same goes for the quotient property. If you have a fraction and you're taking the square root of the entire fraction, you can take the square root of the numerator and the square root of the denominator. So let's practice. So here I have 2 radicals and we're multiplying here. So I can multiply the 10 and the 15 to be 150. And then I can use just one radical. So then I already know that 150 is 10 times 15 because I just did that math. So that's an easy place to start. So 10 is 5 times 2 and 15 is 5 times 3. So I have 1 pair of 5s. Remember, I'm looking for 2 of a kind. So that means I can bring out a 5 in front, but I had a 2 and a 3 left over. So those both need to stay under the radical. But we always do math and multiply things out. So that ends up being 5 root 6, because 2 times 3 is 6. So when I move to part B, I'm noticing that I have a 4 in front and a 5 in front. So I need to make sure I multiply all the numbers in front, and then I multiply all the numbers underneath the radical. So 4 times 5 is 20, and then I have 8 times 18 times 4 underneath. Right? I'm multiplying here, so I can multiply all those numbers, which end up being 576. Now something that is good practice is instead of trying to simplify this right here, I always like to take out my calculator and see if I can just do that in my calculator. So let's go ahead and take out our calculators and type in the square root of 100. So let's go ahead and see what happens in our calculator. If I take the square root of 576, I actually get 24. So I always like to try in the calculator and say, now I know this is 20 times 24 because I just did the square root of 576. So I multiply that out and I get 480. In part C, I have a fraction. So I'm going to do the square root of 27 divided by the square root of 49. Because anytime I take the square root of an entire fraction, I can split it up into top and bottom. So that is the square root of 27, and hopefully we all know, but if we don't, we'll try in our calculator. The square root of 49 is 7. So I still have to reduce the radical on top here, this square root of 27, so I'm going to go off to the side and do the work. So 9 times 3 is 27, and 3 times 3 is 9. So that gives me a pair of 3's with 1 left over. So I can reduce the square root of 27 to 3 root 3, and then still divided by 7. So maybe we'll write that down. This is 3 root 3. So just go ahead and make sure you simplify every radical in your problem. So I'm going to circle part D, and we're going to see how we're doing on time, and I'll let you know what we're going to do with that in just a minute. So what is an imaginary number? An imaginary number is a negative under the square root. So the main thing is that the square root of -1 we define as I. Another important feature of this square root of -1 and I is if I square both sides. The square root of -1 squared is -1 equals I squared. These are the two important things that we're going to use to perform the next few operations. And this holds true for all imaginary numbers. So in part G, I have the square root of -45. So that's the same thing as the square root of -1 times the square root of positive 45. And the square root of -1 is I. And then I have the square root of 45. So anytime you have a negative under your radical, when it comes out front, it's an I. And then you must reduce. So 9 times 5 and 3 times 3 gives me one pair of 3's with a 5 left over. So when I bring my 3 out front, it joins the I out front, and my 5 has to stay under the radical. Remember, it can only take it out if it has a pair. So the square root of -16 is the same as I times the square root of positive 16. I take out the negative, and then hopefully we know that the square root of 16 is 4. So this becomes 4I. And then letter I becomes I, and then I'm going to also break this up into the square root of 4 and the square root of 3. And then the square root of 4 is 2. So this becomes 2I over square root 3. But this is a problem. No radicals in the denominator. So I have to rationalize this. So what I do is I multiply top and bottom by whatever is in the denominator, and in this case that's the square root of 3. So that gives me 2I times the square root of 3. And then remember, when we're just multiplying here, so when we multiply radicals, that becomes the square root of 9, which reduces to this just positive 3. The square root of 9 is 3. So you must rationalize the denominator. So goal number 2 is to perform operations on complex numbers, which means we're going to use real and imaginary numbers. So part A, we're just combining like terms. I have an addition symbol here. This is something we've seen before. 3 plus -5 is -2, and 2I plus 8I is 10I. And that is how our answer is going to look, because we're talking about standard form here, which is always a plus bi, where a is real and b is imaginary. So in part B, I'm subtracting, so I must distribute. So I've got 5 minus 8i minus 2 can't lose those negatives, 9i. So 5 minus 2 is 3. Then I get a negative 17i. Negative 8 minus 9 is negative 17. Part C, I'm multiplying, so I'm going to distribute. I've got 2 times negative 6 is negative 12. 2 times negative 2 is negative 4i. Then I've got 3 times negative 6 is negative 18i. And then 3 times negative 2 is negative 6, but then I times I is I squared. So I've got negative 12 minus 22i, I'm just combining like terms, minus 6. And then if we remember from what we talked about originally with imaginary numbers, I squared is negative 1. So you can look back at your notes on imaginary numbers. We said that I squared is equal to negative 1. So then we can still simplify a little further. Now I've got negative 12 minus 22i plus 6. So negative 6 minus 22i is my final answer in standard form. Part D, I'm just distributing. So I've got negative 3i minus I squared. Now, do you remember what I squared is? I hope so. We just did one. It's a negative 1. So all I'm doing is substituting in negative 1, so that's negative 3i plus 1. But remember, we want this to be in standard form. So the real number should come first and the imaginary come second. So that is 1 minus 3i. So as I move to part E, the first thing I notice is that 1, I have a fraction, and 2, I have an imaginary number in the denominator. And that's a problem. Just like those radicals, we don't want anything bad in the denominator. So I need to use something called the conjugate. And it's important that we know what that is. So any imaginary number in the form a plus bi has a conjugate pair a minus bi. So what I need to do in this problem is multiply top and bottom by negative 1 plus 2i. I'm always just making that imaginary number opposite, so from negative to positive. And it's just the imaginary number that changes. So a plus, or negative 1 plus 2i. So I'm using parentheses because I need to multiply everything in my original fraction by everything in my second. And I need to distribute. So I have 3 times negative 1 is negative 3. Then I've got 3 times 2i is 6i. Got 11 times negative 1 is negative 11i. And then 11 times 2 is 22, and then I times I is I squared. And then I'm going to do the same thing in the denominator. Negative 1 times negative 1 is a positive 1. Negative 1 times 2i is negative 2i. Then I've got a negative 2 times a negative 1 is a positive 2i. And then it's important to keep track of all these negatives because now I've got negative 2 times positive 2 is negative 4. And then I times I is I squared. So make sure you're keeping track of those negatives. So now I'm going to combine like terms. So I've got negative 3 minus 5i plus 22i squared. But remember that I squared is negative 1. An important thing that happens on the bottom is that the negative 2 and the positive 2 cancel out. And that's going to happen every time. That's why we're doing this, because now my I squared is negative 1. I no longer have those imaginary numbers. So this becomes negative 3 minus 5i minus 22 divided by 5, which is negative 25 minus 5i divided by 5. And now we can see that all three terms can be divided by 5, and that's the only time I'm allowed to simplify. So negative 25 divided by 5 is negative 5, and then negative 5 divided by 5 is negative 1. So please rewatch anything if you need to. You do not need to go back and do that other problem. We will talk more the next time we meet. See you then.